Hey, we've got a Tektronix TM500 module here on the healing bench. This is a TG501A time mark generator. As the name implies, it generates time marks. So you can show that on your oscilloscope to help calibrate the settings on your oscilloscope to show the correct spacing and all that sort of stuff on the screen. But this one I bought it second hand, and it's had a little bit of a hard life. You can see it's a knob there's cracked, and there's something going on inside. If I pull that, it's all smashed up, and that's not right. It seems like something's been a bit broken, and it actually has a rod that goes through. There's the outer one goes to a rotary switch, which feels pretty good, but this one here goes to a pot right back in here. There's a rod that goes all the way through, and yeah, there you go. You can see the pot there. That's the back of the pot. And yeah, it's definitely taken a hit. I can actually see that the legs on that pot, instead of being straight, they've been pushed back. So whatever's happened here, it's bent things inside. So I want to repair that because I want to use this thing. So I'm hoping I can fix the pot. If not, I might have to get a new one. Looks like it's 100 ohm. What's the part number there? 311-2351-00. So let's rip this thing open and see what we can figure out inside. I might just take it apart and show you once I'm done, because I've got to take the knobs off the front and take circuit boards out. But once it's all in pieces, we'll have a look and see what we can figure out how to get this thing fixed. Alright, so I got the thing apart with not too much trouble and no damage, which is always a nice turn of events. And that there is where our problem is. That's our main range switch, which turns on this larger shaft, and then this smaller one in the middle, there's the problem. I don't know if you can see, if I give that a twist, there's actually a bit of a bend to it. It's been bent, so I'm going to have to pull that shaft out, decouple it from the little flexible coupling there, and then I'll be able to straighten that shaft up. And then also you can see there quite clearly how that's been smashed back. So I've got to straighten that up and figure out what's going on inside there. Now these pots, they come in sections, and often they're made from a kit. And you can specify how many gangs you want and the resistances and all that sort of stuff, and put it together. In this case, they rivet it. Sometimes they're screwed together, like with long screws. So seeing as this is basically broken anyway, I might drill those rivets out, have a look inside and see if I can repair the damage. And then if not, well, I've got to buy a new one anyway, so may as well have a go at it. So I'll get this torn down a little bit more. I'll be back with some more news once I've got some more progress made. Okay, got the pot out of the circuit board. Didn't leave any traces, which is nice. And we're ready to take it apart. I've already drilled out the rivets. I just used a twist drill and just carefully did it by hand, so I didn't go through too far. They're only brass rivets, so it's pretty easy to do. And yeah, I've pulled them out. You can see how bent they are. Look at that. That's crazy. They are brass, so they are soft, but still, they're like noodles. They definitely need to replace. I mean, I've taken them out. I've drilled them out, so they have to be replaced anyway. But still, that's pretty bent up. So let's give those a quick measure. See what size I need. So that's 1.5 mil. So M 1.5 by, let's say, 25. A little bit longer to put a nut and a washer and stuff on the end. So M 1.5 by 25 mil. That'll be perfect. Hopefully I can find something like that on the eBays or whatever. End plates there, I've just given those a bit of a flatten with the flat pliers, so that they're nice and straight now, so they can go out the way. And the shaft. Now when I pulled the flexible collet, the flexible coupling there, off of the shaft, it just fell straight out. And you can see on the end there's a little groove. So it looks like a circlip or something must go in there. So let's pull this open, take the nose cone off with a little bushing in there, and then looks like a spacer. First section. Oh yeah, there's our end stop. So as it rotates around, it will hit on this little piece here, this little tab. When that goes in like that. Is that in? Hopefully that's in focus. You can see that rotates around and hits on one side, goes back around and hits on the other side. So that's our end stop there. And what do we got there? There it is. Winner, winner, chicken dinner. There is our circlip. So I'll give that a little bit of a squeeze just to close up a little bit, give a bit more tension back. And that will clip on the end of there. So it looks like I can assemble all of this here and put the circlip on the shaft, and then this goes on in the end, and then you put the two end caps or these end plates on, and then screw it all together, bolt it all together, or in the original manufacturer, rivet it all together. So I'm going to give this thing a wipe, get rid of that old grease, put a little bit of new lithium grease in there, and yeah, get some screws to replace these rivets, and put this thing back together. It looks like we can fix it without having to find a new one. Fantastic. So how deep do we want to go? All the way. Look at that. Managed to get this little cap out of here. Just use the scalpel just to lever the thing out and pop it out. And I was able to take this wiper out and give that a bit of a clean. So I'm going to give it just one tiny little drop of the old Deoxit Fader Lube. And that should be perfect. One tiny little bit. That'll do. And then I'll work that left and right, and yeah, put the cap on. That is going to be perfect. Okay, after a little bit of finagling, I managed to get that circlip on. It turns out it doesn't go on that ridge. There's a tiny little groove a little bit further back where it sits there, and that groove actually connects into this little clip, which is the switch. This is a switch section, and that's the potentiometer section there. So all I've got to do is hook that in through that notch and sideways into there, and then that should go together. Look at that. Oh yeah, nice switch action there, and oh, it turns beautifully. Awesome. I think we fixed it. So all I need to do now is stick these plates on in whichever way they go. That one on there and that one on there, and then new screws. Well, it looks like the electronics gods smiled down upon me today. Got this thing back together without too much trouble. It's all nice and straight again. You can see that there. All in one piece, and it turns beautifully. In and out, clicks beautifully. That's perfect. So I end up having to get some M2 screws. I wanted to use M1.4s or 1.6s or maybe even 1.7s, but I couldn't find anything in 25mm long. It all seemed to top out about 20mm. So I was able to drill out the 4 holes to a M2. There was enough meat in the sides there, and they've just got a 1-inch or 25mm long M2 screws holding it all together. Now that I've pulled those pins out and all screwed up with the linkage there, I replaced the stainless steel rod that goes through. It turned out the old one was a bit too bent to be bothered with compared to the price of a new shaft. This 2mm rod is really, really cheap, so in stainless steel as well. So I just replaced it with a new piece, so it's dead straight and dead perfect. Oh yeah, I'm happy with that. Alright, so I got it all back together, apart from the knob on the front, which I'll look at next. All seem to go back together, no leftover parts. And yeah, I got new capacitors in there because why not? We got the new pot sitting down inside there, and also I replaced the little globe there with a white LED. There's a little globe and resistor, which I figured while I had it apart I may as well swap that out, because globes are a semi-consumable item that's going to blow one day. So I'll put a LED in there with a resistor there, so it's an appropriate brightness. Not going to blast your eyes out, but it lights up just enough. And also the resistor here, I've replaced that because that was out of spec. Alright, so now it's all back together. It's time to deal with these knobs. So I've got them here. There's a little middle one, and then this one with a skirt on it, which is broken off. Now that's not such a big deal, because if I glue it, you won't even know. Nice clean break, so I can just put it back on, a little bit of super glue, and that'll be fine. It's just missing this big chunk out the side. And this one here has been glued back together, but you can see there's like a whole section all the way around where it's kind of missing parts. So I can't find these knobs anywhere online or anything, because it seems that these particular ones were only used on this unit. They weren't used on any other unit. So this one here with the blue, and this like little mini one with the blue in this shape. You can get different colours like red and I think all this kind of browny grey colour, but not with the blue. And but I mean, if I found one that was like yellow or red on the bottom or something, it doesn't matter to me. I don't care. But this one here, it looks like that the Tektronix 2235 oscilloscope might use the same top section, but it's got a different skirt in that there's different numbers all the way around. So I could get one of those and like take the skirt off and swap them over, but they're expensive. To find one on eBay, I found one for like, including shipping and the cost of the knob, is like $40 or so. It's a bit ridiculous. So I'm not going to be buying a new one for now until I actually find one for a reasonable price. But I went down to the hardware store and I did find this stuff. Katatori-kun. Katatori means to take a mold or like to take a shape. Kun is just an honorific, like it's a cute honorific, like Mr. or Mrs. or Miss or whatever. So yeah, it's just like a play on, making it cute, play on words. But it's basically a soft plastic which can be used to take a mold of something. So what you do, it says on the back, you put it in hot water, 90 degrees, and this plastic softens up, and then you can kind of mold it around your shape. So it's a little like a semi-translucent, semi-transparent block of rubbery plastic, and I'll put that in the hot water. It goes all soft like putty, and I'll be able to mold it around a part of this knob that isn't damaged, and then I can use that to transfer that shape to the side of the knob that is damaged. Fill it with some putty. I've got some JB steel stick here. I also got some liquid JB Weld if that ends up being easier, and I can then make the shape out of JB Weld using this as a mold, peel that off, and it should be pretty much perfect. It'll be a different color, of course, but that's not a big deal. Like, I'd rather have an intact knob, even if it's a slightly different color for the patch, than have a broken knob. So I'll probably do the same for this one here as well. This little knob here, and see the big chunk taken out. So I might fill that with some JB Weld. Might be able to take enough of a mold of that to transfer it around section by section, and get that one done as well. Alright, so I've got the plastic here in the hot water. I wonder what sort of plastic this actually is. Might actually be able to do this with hot glue. I wonder if you could do it with hot glue. I wonder if this is hot glue. It's not sticky like hot glue though. Like it's kind of holding its shape. Alright, so that looks like it should be pretty good, I think. I might just mold a little bit more around. Apparently you can reuse this stuff too, because it's just some sort of plastic, and you just put it in the hot water again, and it softens up all over again. So once that's cooled down, I'll take it out and we should be good. Alright, so I got my mold there. That should fit just nicely there, just like that. So I'm hoping what I can do is get this stuff, the old JB Weld steel stick. I'll need that up. Got the gloves on because this epoxy stuff is an irritant. I'll put in enough around here. Hopefully I'll be able to estimate enough, and then squeeze this down and it should mold the shape. That's what I'm hoping. That might work. See what happens. Something like that. Alright, I get some rubber bands. Fingers crossed that works. I've got this leftover bit, so when that goes hard, that in there will be hard. Alright, so this little test piece, the leftover bit, it's not rock hard, but it is very hard. So let's see if it turned out. I have never done this before. Hey, that's looking pretty good. I have to give it a little bit of a trim, but that might not be too bad. It's not perfect, but it's not bad. I might give it a second go. Looks like I didn't quite get it into the shape quite properly. I might have put a little bit too much in there, so it's kind of pushed out a bit. So I'll give that a second go. But that has proven the concept at least. I was able to rip it out then because it's still like a little bit soft. So I'm going to have another go at this and see if it works. Hopefully I can get this looking good. That is looking pretty good. A little bit of carving, a little bit of love, a little bit of a tickle here and there, and that's come up quite nice. So basically, once I took it out of the mould, I used a blade like this. It's like a little chisel blade, and obviously this was not there, but I was just running from that side, just running it along the edge, like nice and flat, just to carve it so it's perfectly straight, and then the same at the top, and then I was able to get it sideways in each groove, so that where the groove stopped, because it was broken, I could continue that on just nice and straight. And that is something I'm happy with. Not perfect colour match, it's grey compared to green, but it looks pretty good, I think, for a physical shape. So I'll continue on with the small one, fill all that in, and then we'll get this mounted to the unit and see if it works. Alright, time to give this thing a test. I won't run through the complete range of tests, I'll just do an abbreviated version just so we don't get too bored. But we've got this thing plugged into the power supply, the TM502A enclosure. Knobs are on there, all nice and fancy, looking pretty handsome if I might say so myself. I'll insert a close-up picture so you can see exactly what it looks like. We've got a universal counter here which we're going to use for one or two tests. This is actually a subject of an earlier video. If you look back in my history, you'll see where I replaced the oven control crystal oscillator in this to make it more aligned with the original Tektronix design. The previous owner kind of bodged one in that was a little bit how you doing, so I've improved that. Also, we've got our 10 megahertz frequency reference, which is also the subject of a previous video. And we've got the frequency divider, once again, the subject of a previous video, set to 1 megahertz. So we've got 1 megahertz coming out of this BNC here. So this is all ready to go. We've got the Tektronix scope here. We'll see how we go with the screen. Normally I inset the picture, but we'll see how we go with it all set up like this because it's a nice kind of panoramic view of all the test equipment ready to go. And we'll see how it all works. So we've got this turned on. You can see the white LED there, which I replaced the little grain of wheat bulb. And if we turn that to 1 microsecond, and if we pull this out, we should see some numbers. So basically what this dial does is this lets us adjust whatever is here, in this case 1 microsecond. We can go up and down a certain percentage. So we should be able to adjust about 7.5-ish, at least 7.5 up and down. So you got fast and slow, up, down, left, right, whatever you want to call it. So we got 7.5 in the fast, and if we turn it down, 7.6 for slow. So that's fine. That test is good. So if we turn that to 0.1 microfarad, 0.1 microsecond, and I'll grab my BNC cable with a 50 ohm terminator, HP. I hope Tektronix doesn't get too upset about that. If we plug that in, we should see 10 megahertz, and we're getting 10.0000 megahertz. Good enough for me. If we pull this out, if we go all the way to fast, actually not all the way, to 5%. That should be, according to the paper, between 10.49 and 10.51. So we're almost at 10.5, so that's perfect. If we turn that down to 5% slow, that should be between 9.49 and 9.51. And that's almost exactly 9.5. So that test also is perfect. No worries at all. So the next one is to plug into the oscilloscope. So we're going to plug in from the trigger out, and then we want to set this up. So 0.1 microsecond, that's all good. 0.5 volt and time division 0.1 microsecond. So what we should be seeing is the pulses coming out of this, or the time marks, and we've got it set to 100 nanoseconds, which is 0.1 microseconds, and we're getting 1 pulse per division on the screen. So that's fine, and we can run through a couple of these. So let's go to 0.5 microsecond, and if we change that to 500 nanoseconds, we're getting the same. 1 pulse per graduation, or 1 pulse per screen marking. We can go up again. This is 5 microseconds. Yep, looking pretty good. 50 microseconds. Again, looking pretty good. 0.5 milliseconds. Yep, this test is all going to be good. So we can shortcut the rest of those. 5 milliseconds, all good. And the voltage is, you check the voltage as well, it's got to be above 1 volt, and I'm getting about 1.8 volt on all the tests. So the output's nice and strong, and the timing is good too. So the next test, we need to connect from here into here. So we're going to compare the oscillator in here to this oscillator. And what we'll have is these pulses. Once I set it up, we want the external, and that's got to be set to there, 1 microsecond. Alright, I don't know if you can see it, but when these are out of phase, the pulses end up walking across the scope screen, and the faster that they move, the more out of sync they are. So assuming that this is spot on, and this is where like a rubidium or a GPS disciplined oscillator comes in handy, where you can make sure you're exactly perfect, but I'm going to assume that this is perfect. Then the more that this is different from that, it'll walk left or right depending on if it's fast or slow. So this looks like it's slightly slower. The spec is that we want it to a rate of less than 6 divisions over 10 seconds. So if we count 10 seconds, it can't change more than 6 divisions on the screen here. And as I've been talking, you can see it's a lot slower than that. So we'll give it a second to line up with a division. As it's coming across, it's a bit slow, but it's working its way there. So right about now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in 10 seconds, even more than 10 seconds, we haven't even gone one division on the graticule, the lines on the screen there. So that is almost spot on. So that's fantastic. So there are a few other tests just to go through different ranges and stuff, but we're not going to worry about that because I'll do that off screen. And if a few of these ranges are good, pretty much the rest are good anyway. So that's a thumbs up. This thing is working well, spot on, nice strong output, it's accurate. So that's all we got for this one. We've fixed the potentiometer inside that was smashed in, we've repaired the knobs, and it's testing perfect. So that is thumbs up. Alright, I hope you found that interesting, or maybe even a bit informative, and stick around, we'll see you next time.